everyone! Welcome to DNAce Learning Center. I'm Teacher Sab and I hope you are energized and ready to explore the world of carbohydrates, specifically disaccharides. Let's begin! A quick review: carbohydrates are organic molecules made up of carbon, hydrogen, and oxygen. They generally follow this formula. The simplest units are called monosaccharides or simple sugars. When two monosaccharides join together through a glycosidic bond, we form what we call disaccharides. If we add more, we get polysaccharides. Before we dive into today's topic, let's have a coffee break. What do you want to go with your coffee? Sugar, milk, or bread? Go ahead, pick. Great choice! Did you know that carbohydrates are present in these foods? Yes. Let's uncover which carbohydrates are present in each. In table sugar, the carbohydrate present is sucrose. In milk is lactose. And in bread is maltose. Turns out many of the foods that we consume, including table sugar, milk, and bread, contain carbohydrates, including disaccharide. They provide energy in the form of glucose, function as energy storage, help with cell signaling, and serve as structural materials such as cellulose in plants and chitin in insects and crustaceans. In this lesson, we will explore more about them. For our learning outcomes, by the end of this lesson, students will be able to define disaccharides and describe its general characteristics, explain the process of disaccharide formation through glycosidic bonding, identify common disaccharides such as sucrose, lactose, and maltose, determine the systematic names of common disaccharides based on components and linkages, draw the structure of the common disaccharides, recognize the importance and applications of disaccharides in daily life. In this video, we will be discussing about disaccharides, its definition, and formation via glycosidic bonds. Let's dive in! What is a disaccharide? A disaccharide is a type of oligosaccharide made up of two monosaccharides joined by a glycosidic bond. They're commonly found in nature and play important roles. Let's look at three important disaccharides and the monosaccharide units they're made up of. First, we have sucrose. Sucrose is made up of glucose and fructose. Next, we have lactose, which is made up of galactose and glucose. And lastly, maltose, which is made up of two glucose monosaccharide units. It's time for a checkpoint! How many monosaccharide units form a disaccharide? That's correct! 2 monosaccharide units make up a disaccharide. Very good! Now let's discuss the process of disaccharide formation. We have what we call glycosidic bonds, which is a covalent bond that forms between two monosaccharides through the dehydration synthesis reaction, meaning a water molecule is removed during the process. Here's how it works step by step. Two monosaccharides approach each other, then their hydroxyl groups interact. Next, a water molecule is eliminated and a glycosidic bond forms. And finally, a disaccharide is produced. Now let's take a look at the specific linkages in our three main disaccharides. Let's first have sucrose. Sucrose has an alpha-1,2 glycosidic bond. Next, lactose has a beta-1,4 glycosidic bond. And lastly, maltose has an alpha-1,4 glycosidic bond. Now, the alpha or beta pertains to the position of the OH at carbon 1 of the first sugar, and the first number pertains to which carbon in the first sugar is forming the bond, and the second number pertains to which carbon in the second sugar is being bonded to. It's time for a checkpoint. What molecule is removed during glycosidic bond formation? Correct! It's water or H2O. Now let's learn how to write the systematic names of disaccharides. Let's start with maltose. We have discussed that maltose is made up of 2 glucose units linked by an alpha 1,4 glycosidic bond. Keeping that in mind, let's build its systematic name. We start with the acceptor sugar. This is the glucose that retains its free anomeric carbon. Therefore, it stays a pyranose ring. So we name it alpha-D-glucopyranose. Now, we attach the donor. The donor is linked to the 4th carbon of the acceptor through oxygen. So we name it 4O-alpha-D-glucopyranosyl. We combine the two parts, we get 4O-alpha-D-glucopyranosyl alpha-D-glucopyranose. Next, we have sucrose. This is the systematic name of sucrose. Finally, we have lactose. This is the systematic name of lactose. Notice how sucrose ends with a side and maltose and lactose ends with an ose. This is because sucrose is a non-reducing sugar, meaning there is no free anomeric carbon, while the others, which is a reducing sugar, meaning there is a free anomeric carbon. It's time for a checkpoint. What is the systematic name of maltose? Correct! This is the systematic name of maltose. Great work today, everyone! Let's quickly review what we've learned. We've talked about carbohydrates, especially disaccharides, like sucrose, maltose, and lactose. We've talked about how they form through glycosidic bonds and how their names and structure give us an understanding of how they behave. You can access the summary notes and summative tests by scanning the QR codes presented on screen. And that's it! Thank you for watching this video. Make sure to click the like and subscribe for more videos. Keep exploring and stay curious. Bye!